Yeah. So what we discussed yesterday, guys. So we discussed about the RDS, we discussed about the S3, and we discussed about the IAM also, right, guys? So
Yes,
today
sir.
we will discuss about the VPC, guys. So what we are discussing today, we will discuss about the VPC. Sorry, notepad, the paint. Guys are able to see my screen, right? Guys are able to see my screen?
Yes, sir.
Yes,
Yeah.
sir.
Yeah, very good. Thank you. So this is AWS, right? So this is the so today we are discussing about the AWS. Yesterday we discussed about the auto scaling, right? Right, guys. The tournament and the load balancing we discussed about, right?
Yep.
You understood, right? Yeah, I will discuss today. Uh,
Sorry, is this last class?
yeah, today is the last class for you guys.
Okay.
So tomorrow you have a try, right?
Yes, sir.
Okay, all the best, guys. So this is the
Yeah.
AWS. So what we learned till now. So we learned the EC2 instances, the services, guys. AWS services. What services we discussed, guys? We discussed the compute. In the compute, we discussed about the EC2, right? EC2 service. Then we discussed IAM, I identity and access management, IAM service, right, guys? So this is for authentication. So this is for the authentication purpose. And the third one is S3 bucket. This is nothing but a, so this is nothing but a storage. Guys, did you guys watch it the recording or not, guys? You watch it, right? The storage and RDS also we discussed about RDS. So the relational database, guys, relational database. And so today we are discussing about the VPC. VPC is nothing but a virtual private cloud. So virtual private cloud network, guys. So for example, so yeah, networking. So in networking, we call it as a VPC, virtual private cloud. So IP addressing, subnets, so internet gateway, routers. So Amazon VPC terminology. So what are the terminology? So what are the terminologies we are using in the Amazon VPC terminology? So something like a VPC subnets, route tables, so elastic IPs, internet gateway, a VPC NAT gateway, network ACLs, and security groups. So Amazon VPC definition, guys. So what is the Amazon VPC definition? Amazon's definition of a VPC is a Amazon Virtual Private Cloud. Amazon VPC enables you to launch Amazon Web Services resource into a virtual network. So what is that, guys? A virtual network that you are defined. This virtual network closely resembles a traditional network that you had operate in your own data center with the benefits of using scalable infrastructure of AWS. Infrastructure of AWS. So for example, so in our AWS account, you created a private like a data center. What is that, guys? Data center. So in this data center, there is a network. There is a network in here. So So separate network will be created. The separate network is nothing but a VPC. So separate network is nothing but a VPC. In this network, you can enable anything. If you want to enable the firewall rules, you can use the network's security groups. You can use something like I will show you. Yeah. So for example, so this is your AWS account. This is your AWS console. And in this console, you logged in as a something like a region. So in the region, you created a VPC. What is guys? Virtual private cloud. This is nothing but a network. So in the network, so you need to create a private public IP address subnet. So this is nothing but a subnets, private public subnets, private public subnets in the availability within the availability zones. So and you can create the router. So router means something like so this is the 172 dot 31.000 something. This is 172.32 for example. So you want to get the connection between Tuesday, right? So over the internet, you can use the right tables. You can use the route tables and over the internet gateway. If you want to connect outside of the network also by using the internet gateway, by using the internet gateway. Guys, now you understood? Now you understood? So VPC is a separate network. They are creating for you. The separate network is creating for you guys. So here, so what is IP address? First of all, you need to know, right? What is IP address? So what is subnet? So what is internet gateway and routers? You need to know, right? You need to know these things. What is IP address? Does anyone knows what is IP? IP means Internet Protocol. So Internet Protocol. So you will get a IP address, right? So once you launch the instance, definitely you need to get the IP address. The IP address is nothing but 192.168.56.101. For example, this is the IP address of your server. So Oracle VirtualBox. So for example, this is the data center environment, guys. Let's see which IP address is assigned to this server. So how it gets the IP address? How it's get the IP address? Let's see. So what is the username, guys? Logged in as a root. Password is Red Hat. So for example, IPA. So what is the IP address I'm getting? I'm getting the IP address. So 192.168.56.101. For this server, I'm getting the IP address of 192.168.56.101. So here in AWS, so we are getting the public IP and private IP address. For this server, we are getting the public IP and private IP. So what are those IP addresses? We'll check it in the AWS.
Sir, are you in Hyderabad?
Yeah, I'm in Hyderabad only.
What's the location, sir?
Kukatpalli, JNTU.
Kukatpalli. Need to meet you one time, sir,
Yeah, sure.
to discuss about this AWS.
Yeah.
If you're possible, give me one date and I'll be present in that day.
So weekends, guys, if you want to meet, you guys can come on weekends. Saturday, Sunday, I'm available in the institute.
Sure, sir. We institute at 360 degrees.
No. So, so I will give you my email address and mobile number. You guys can contact with me.
Yeah, sir. Sure.
it's in pending state. Once it is running, so I will show you the IP address of the server. You see, so this is the private IP of the server. So on public IP we'll get it, guys. So private IP, every server having the private IP, the VPC, right? So what is, so we are selecting VPC. So here VPC, so what are these, a virtual private cloud? Then you will provide your VPCs, subnets, route tables, internet gateways, and ingress only internet gateways, carrier gateways, DHCP endpoints, elastic IPs, managed IPs, endpoints, endpoint services, NAT gateways, peering connections, and security. Security will be NACL, security groups, or firewalls, or network firewalls. So the firewall policies, network firewall groups, so TLS encryption, so the virtual private network, so virtual private network. Yeah, guys. So VPC, subnets, route tables, internet gateways, ingress DHC points, NAT gateways, network ACLs, VPC peering, customer gateways, virtual private gateways, site-to-site VPN, running instances, endpoints, instance connections, endpoints. So these are, guys. These all are the network things. So for basic, you just know IP address, subnets, internet gateways, and routers is enough, guys. Okay, security groups. Yeah, I will show you guys, no worries. Yeah, so before that we need to know what is IP address, right? So before that we need to know what is IP address. I will show you. Where is that network? Yeah, yeah, basic networking, guys. You know also, right, guys, the network, so LAN or WAN. So what is the role of CCNE? Something like a LAN is nothing but a local area network. WAN is nothing but a wide area network. So what is LAN, WAN? So I will tell you, guys. I will tell you. So LAN types of networks is nothing but a LAN, WAN. Types of networks is nothing but a LAN and a WAN. So local area network. So LAN is nothing but a local area network. Network devices connected to the limited geographical area within the room, within the building, and within the campus. So no service provide existence. So computers are connected with the switches. What is that, guys? Switches, WAN, wide area network. Network devices are in the distant areas. It is in different cities, different countries. Service provider existence. Networks are connected with the help of routers. So with the help of, here in the local area, it connected with the switches. It connected with the routers. WAN is connected with the routers, guys. So this is nothing but a LAN, right? So LAN means within the geographical area. For example, in our office. In our office is connecting with the switches. You can connect it with the switches. Then you able to communicate with each other. So without switch, you cannot communicate with each other. We cannot communicate with each other. That is nothing but a LAN. So LAN not providing the internet. LAN not providing the internet. So WAN it will provide the internet, guys. So you want to connect from the Hyderabad office to Delhi office, we need a router. A router is nothing but your Wi-Fi router, right? So how many of having a Wi-Fi routers, guys? So which ISP provider? Internet service providers like Jio, um, what
Act.
is Act, right? They you have a router, right? So in router having the IP address, router having the public IP address. So from that public IP address, you are getting our Wi-Fi from your local devices, right? So how we can get it? So how we can get it? The internet from Hyderabad to Delhi by using the network. By using the router, you can use the routers. So your router is nothing but your Wi-Fi, same like as you can connect from router to router, then you will get the connection between these two. So who will provide that? Who will provide that? ISP providers. ISP providers. Yeah, guys, every server having the NIC. NIC is nothing but network interface card. So this is the NIC card. For example, so these all are the NIC cards. NIC card 1, NIC card 2, NIC card 3, adapter 1, adapter 2, adapter 3. So these three NIC cards having the IP address. These three NIC cards having the IP address. So for example, this is the one IP address. So this is the one IP address. This is the one IP address. This is one NIC card, two NIC card, three NIC cards. So every NIC card having their own IP address gives the network service to that computer. Every computer must have a NIC to communicate with each other, each other. So your laptop also having the NIC cards, right, guys? Switch is nothing but this, guys. So from one NIC card, from one Ethernet card from your computer, one Ethernet card from the switch. So you will transfer the data from by using switch. Router is nothing but to communicate between the different network. Same network we can use the switch. Different network we can use the router, guys. Different network we can use the routers. So something like a binary number system, you already knows, right? Zeros and ones. Octal number system, 0 to 8. 0 to 7, decimal 0 to 9, hexadecimal 0 to 9, and A to F. A to F. Yeah, guys. So every NIC card having their address. So there are two addresses are associated with the NIC card: physical address and logical address. What is the physical address? So physical address is nothing but a MAC address, media access control. So logical address is nothing but a IP address. IP is nothing but a internet protocol. Internet protocol. How will we get? We'll get the L3 address. This is the L2 address. So permanent. This is the logical, can be changed. This is the 42 48 bit, this is the 32 bit. So how it comes from 192.168.6.1? So 32 bit means 8 bit, 4 bit of, so 8 bit, so something like 8 bit is nothing but a octant. So 1 octant, 2 octant, 3 octant, 4 octant, 8 fours are 32. That is the reason. So this is the IP address comes into the picture. So so this is a this is a IP address of the logical. This is the logical IP address. So it comes from the four dots. So one octant, two octants, three octants, and four octants. Guys, understood? Understood? Yeah.
Yes, sir.
How to assign a IP address? You also know, right? How to assign the IP addresses. So for example, yeah, in the internet protocol, you can use the IP address. Yeah, you can assign the IP address and subnet mask. What is subnet mask? I will tell you guys. No worries. So how to check the IP addresses? How to check the IP address? Something like if config to check the IP address. IP space here you can get it in for the Linux, guys. If config for the Windows, IPA for the Linux. Ping. So ping is nothing but to check the connectivity. So you check the connectivity. Connectivity server is up and running. Are you able to connect to the server or not? You can get the ping command. You can get the ping command, guys. Yeah, guys. So HTTP protocol, SSH protocol, DHCP, DNS, what these protocols? System architecture, hardware and software is called as a system architecture. Systems with a different architecture can communicate because of they have same protocols. So what is a protocol? Protocol is a standard set of rules. So what is a protocol, guys? HTTP protocol. Through HTTP protocol, you will get the website from the web server, right? The HTTP is nothing but a hypertext transfer protocol. What it is a protocol? Protocol is a say standard set of rules, operation sequence to carry out a specific task. So what it is a protocol is doing? Operation So operation. So this is the server, right? You want to you want to get it from this web browser. So how it operate, how it the operate, something like you will get the pages from here to here. So that is nothing but a operation sequence to carry out a specific task. Example DNS, DHCP, HTTPD, SSH. These all are the operation sequence to carry out a specific task. What is a port number? Port number is a channel of a communication. A system can initiate multiple sessions with a destination computer. Port number is a channel of communication. You are hitting, right? You are hitting, some people, other people are hitting, so many people are hitting this website. Many people are hitting this website. A port number is a channel of communication. A system can initiate a multiple sessions with the destination computer. Unique number is required to identify that session. This number is for the port number. So port number is a 16-bit value. The range is from 0 to 655. 0 to 655. Systems uses two port numbers to identify the session. They are called as the source port number and destination port number. No need, guys. Yeah, the port numbers and protocols. HTTP hypertext transfer. This is AET. HTTPS hypertext transfer protocol secure 443. System sends the some control information along with the data. This is reason the data is directly forwarded to the correct destination. This control information is called as a header information. Yeah, guys. So do you know the OSLA is the everything will be related to this physical, so physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So if you guys don't know, you guys can check it once time. So so this is the heart of the OSL layer, transport layer. So network, data link, physical, everything will be hardware layers. So after that, everything will be software layers, session, presentation, application. Yeah, transport layer. So transport layer is nothing but a TCP UDP, right? You also know TCP, transfer control protocol, UDP, user datagram protocol. So right, transmission control protocol and user datagram protocols. It is not possible handle whole data as a unit. Just you know, guys. TCP UDP, transmission control protocol, connection oriented, reliable and slow. Yeah, guys. So network layer, it provides a logical IP address scheme. If the header is added to the network layer to choose the best path to the destination, carry the data to the chosen path. Guys, from IP, you will get it understood. So data link layer, physical layers, OSL layers, network, IP addressing. Guys, from this. Yeah. So IP address is a 32-bit value. We already discussed it, right? 32 IP address is the 192.168.56.1. So the IP address is 32-bit value from 4 octants. Every octant is nothing but a 8-bit. 8-bit, 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 4 octants. 0.0.0.02, 255.255.255. So something like 111111111111. So from 0 to 255, every IP address from 0 to 255. You see, guys, 0 0 0 0 0 0 from last side. So, so you check. Yeah. So from 0 0 0, right? So here 0 to 255. Also from here, 1 2 3 4 5 6 7 8 9. From here, first you need to change from here. So 1 2 3 5 4 5 6 7 255. Then this one. So 1 1 0 1 2 1 3 1 4 1 5 1 6 1 255. 0 to 255. 1 to 255. 2 to 255. 3 to 255. 4 to 555. 255. So 5 to 255. 6 to 0 to 255. So same like as 255 here. So then again here 255. Right. You need to change the IP address. Here you see, here you see, it changes the 000 to 0, 01, 02, 03, 04, 05, and so on 255. Then again 1.0, 1.2, 1.3, 1.2, 1.1, 255. So 2.0, 2.1, 2.2 up to 255.255. Then so here 1.0, 0, 255. Then 1.0, 1.1.20, 1.1.255 up to 255. So we have a lakhs of IP addresses will be assigning. So up to 255, 255. Guys, understood? So IP address from 0 to 0.0.0.0.0 to 255.255.255 are classified into 5 classes based on the first octant value. Based on the first octant here 0 to 255. 0 to 255. They are divided as a classes. So class A from 0 to 127, class B from 128 to 191, class C 192 to 233, class D 224 to 239, class E 240 to 255. Guys, you understood? 0 to 255, how they are dividing? They are dividing the classes. Class A is nothing but a 0 to 127, 128 to 129, class B. So 191, class C 192 to 223, class D 224 to 233, so class E 240 to 55. So class A, class B, class C are used for the private IP addresses. You can use the private IP addresses. We don't need to purchase these. So the last two are D and E are the public IP addresses. So whoever providing the ISP providers, right? Those providers we need to purchase it. We need to purchase it. First three A, B, C are the local and private. So class A priority bit 0 from 2 to 127. So priority bit 10, 128 to 191, C 192 to 223, class D 222, 220, 224 to 239, class E 240 to 255. Yeah, guys, IP address has 4 octant. Every octant contains 8 bits. So this is 8 bits, this is 8 bits, this is 8 bits, 8 bits. So every octant contains 8 bits. IP address has 4 octants. 1 octant, 2 octant, 3 octant, 4 octant. So 4 octants. 192.168.6.101. So this is the IP address of the server. Guys, subnet mask value defines the properties of the IP addresses to which it can communicate and to which it cannot communicate. Subnet mask value defines the network component and the host component of an IP address. It will define the host component and host component. It will display the host component and host component of a network component and host component. IP addresses uses subnet mask to find out the boundaries of the network. Subnet mask value is a drive of the IP addresses. Network bits are always represented with zeros and ones. Zeros and ones. Subnet mask structure. Something like subnet mask structure for the class A. Only one network path, three host path. Only one network path and three host path. So we can change the IP address of these three. We cannot change it here, network part, right? 255.0.0.0. So if we use the class C range, so class A range, you will get this IP address. So class B subnet mask structure. So double N and double H. Double H means host names. So these two ways you can change the host names. You can change the host name 255.255.0.0. So then the class C. Class C is a subnet mask value structure. So how many? So three network tabs and one host tab. 255, 255, 255. Is understood? Yeah, this is the So number of work.
We have network and hosting constraint
Sorry,
for class D.
class D, yeah.
Yes, sir.
Class D.
How the network path and hosting path will be
Yeah, so
considered.
that is the public address. Public address. We will not provide the network and host because of these are the private address for the class A, B, C, D. So there is no public private for the. So everything is public. The fourth and the class D and class E are the broadcast address and public address for what they are using. They are using for the public and public address. These three are the class A, class B, class C are the private addresses. Okay. So how many? So address is nothing but a systems. For example, so this is your company. Your company having how many members? Your company working 255 members working, or 250 members working. So 250 members working. You are choosing the classes. Which class you want to choose? Class A, class B, class B, and class C. So which class? These all are the private IP addresses. What are these are? These are the private, and so we are not using the class D and class E. These all are the public ones. What these are? These all are the public ones. So these all are the public ones. These all are the private ones.
Sir, like when we will use this public and private, sir.
Sorry.
Like when we will use public IP address and private IP
Yeah, I
address.
will tell you. I will tell you. So
Okay, sir.
So ISP providers are using. ISP means what is ISP? Internet service providers. What are those? Internet service
Provider.
providers. Who are the internet service providers, guys? Who are the internet service providers? Act,
Geo.
Geo Fiber, Airtel Broadband. So these all are the ISP providers. ISP providers uses the public IP addresses. ISP providers are using the public IP addresses. Which IP addresses, guys? Public IP
Public.
address. IP address. So in the normally, so in the people, something like 255 members are working in our company. So which private addresses we are choosing? Class A, class B, class C. I will tell you. Yeah, class A. So class A, how many people can work? So 16 lakh 77,000. So 16 lakh 77 167 lakhs, right? Yeah, 16 lakh 77,000. No. So
167 lakhs, sir.
yeah, 167 lakhs 77,241 people will use this class A network. Means so every. So 250 members, right? 250 members are taking the 250 laptops or 250 systems or some of the laptops and some of the systems. So we need to get the IP address, right? So IP each laptop or each desktop having the IP address, right? So something like 192 dot so 168.56.101, same like. So every IP address is getting. So if you use the class A, how many people are you connect with this? How many people are getting the IP address? 167 logs 77,218 218 or 216, for example. So these many peoples. So if in our company having these many peoples, you can use the class A network. So class B network. So class B network is nothing but a how many people are there? So 65534 means 65,534 people. If your company having the all the people are 6,000 65,534. So below 1 lakh, you guys get this class B range. Class B range. So something like if you people having only 256 people, In our company, only 256 people or 250 people. So which network you can see, guys? Which network you are using? Which classes of IP address you are using? Class C. For example, yeah. So we are using class C. So what is the range of the class C? I will show you. What is the range of the class C? I will show you. So what is a network address? What is a network address? Network address is the identification address for all the systems in the network. The system with the same network address can communicate with each other. Systems with a different network addresses cannot communicate. Same IP addresses we can communicate, but different IP address we cannot communicate. So how we can communicate with the router? We can communicate with the routers. These are the network address, class A, class B, class C. So what is the broadcast address? Broadcast address is used to deliver a broadcast message to all the computers in the network. The system with the same network address can have same broadcast address. All the system in between network address and broadcast address from the logical network to communicate with each other. Network address and broadcast addresses are the boundaries of the networks. They cannot assign to the computers. So how to find out the network address? So I identify the class of IP address and subnet mask structure. Replace the host partition to 0. Perform a logical and operational IP address and subnet mask value. How to find out a broadcast address? So for example, in your system 10 dot, so 10 series, so 10 series, 172 series and 192 series. So 10 series is nothing but a, guys, 10 series is nothing but class A. So 172 series is nothing but class B. So 192 series is nothing but class C. So 250 members, if you have a 250 members, you can use the class C. So what is the IP address? You have a class 2 IP address. Yeah, class A. So 10.2 So something like, so 167 lakh 77,254 host we can use for the class A network. Class B network. So we are 65536 host. We can communicate with each other. This is the class B. Class B is a 172. So class C is nothing but we have. So we are using 254 hosts. Something like class C. So 192 series is nothing but a class C. So if you want to, if in your company having 250 members, which class C you are using? What is the range of the class C? 192.168.192.168.56 or something. So 56, 1, 0, 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12 up to 255. Guys, understood? This is nothing but a classes of networking. Classes of networking. Now you understood, right? Right, IP address. Class A
Yes.
0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, Class E 240 to 55. So for Class A, one network, 3 host. Class B, 2 network, 2 host. Class C, 3 network, 1 host. So 126. So here 254. If you in your company having below 254 people, you can use the class C. If you in your company having above 255, definitely you need to use the class B. So something like if uh, if 20,000 or something like a 2 lakhs or 97, 91, so whatever it may be, guys. So after 65,000, you can use the class A, right? So so class D and class A, multicasting purpose and reserved IP for IT. So IP address related organization. Yeah, guys, private IP address. Yeah, IP address present percentage. IP addresses related organization, INNA, Internet Assigned Number Authority, and ICANN, Internet Corporation of Associated Number of Numbers and Names. So these two are the using for the networking. Private IP address. The IP address are not routable in the public network. Used to communicate within the private network only. Internet access is not possible within the private address. So defined in the RFC, Class A, Class B, Class C. Guys, understood? Social IP addresses. This is the 000 is the network reserved for the default routing, cannot assign to the system. So 127 is the 127 is our loopback IP address. That is the NIC. So class D is nothing for a multicasting. Class E is nothing but a reserved for researching, right? So subnetting. So subnetting is nothing but a logically breaking a major network into a smaller network is nothing but a subnet. So logically breaking a major network into smaller networks is nothing but a subnet. So advantage of subnetting: reduce the wastage of IP address. Subnetting procedure: increase network bits in the route in the subnet mask value from last to right. So for this 255.255.0, so for this 255.255 dot something like 00, so here 0.0.0 Guys understood?
Yes, sir.
You guys watch it on the based on the network, guys. You will get the subnet mask. Yeah. So this is nothing but a basic networking concepts, guys. Basic networking concept. So you already know. Now you understood, right? What is a subnet, route table, elastic IPs. Elastic IP is nothing but a public IP. Internet gateways. VPC, NAT gateway, network ACL, security groups. So Amazon's definition of a VPC: Amazon Virtual Private Cloud. So resources into a virtual enables to launch Amazon Web Services resources into a virtual network that you are defined. This virtual network closely resembles a traditional network that you had operate in our own data center with the benefits of using scalable infrastructure. So with the benefit of using scalable infrastructure. Okay. Yeah, Amazon VPC diagram. This is the Amazon VPC diagram. Something like AWS VPC, then the availability zones. Availability zones in the private IP, public IP is EC2 instance. Every EC2 instance having a private and public IP addresses to connect the network. So private and public address default subnets. We have a default subnets. So AWS is a cloud. Cloud is nothing but a predefined environment, right? So if you are not creating any defined network, so it's automatically created everything. A default VPC is created, default subnets is created. You can use the if you can create your own subnets, or else if you are not creating any subnets, it automatically take in the default subnet. What are the default subnets? This is the default subnets. So this is the default subnets. Something like default subnets of a VPC, default subnet of the EC2 instance. So guys understood? So this is a VPC diagram. So custom VPC, how we can custom a VPC. So this is our AWS. So in the outer AWS, if you want to connect the data center, you need a internet gateway. So from VPC, so you have a availability zones. So public subnet, these are the private IP address. So this is the custom VPC. So this is the default VPC and this is the custom VPC. Yeah, understanding the CIDR IPv4. So something like IP address will be two types. One is IPv4 and IPv6. IPv4 is nothing but a 32-bit architecture. So IPv4 is a 32-bit architecture. So as of now, we are using the IPv4 architecture only. So we are not started the IPv6. Classes inter-domain routing. What is CIDR block, guys? So CIDR is nothing but a classes inter-domain routing. Classes inter-domain routing is nothing but a CIDR, a method of allocating IP addresses used in security group rules and AWS networking in general. So they help to define IP address range. So we have seen www.xxx.yy.zzz/32. So it's a nothing but a one IP. So we have seen 0 to 0 slash all IPs. So but we can define 192.168.0.0.0260 slash 26 to 192.168.0.02. So 192.168.0.63. So how many IP addresses, guys? We have a 64 IP addresses. So understanding the CIDR IPv4, a CIDR consists of a two components. A CIDR consists of a two components, base IP, refreshment and IP contained in the range. Example, so 10.10 series, 192 series. Subnet mask define how many bits can change the IP address. Example 0, 24, 32. So can take the two forms, 255.0000. So it is nothing but a 16 is nothing but 255.255.000. 24 is nothing but 255, 255, 255. 32 is nothing but 255, 255, 255. So understanding the CIDR and the subnet mask. The subnet mask basically allows part of the underlying IP to get the additional next values from the base. Guys, understood? So these are the IP addresses values. So understanding the CIDR little exercise. So public versus private IP. The Internet Assigned Number Authority established a certain blocks of IPv4 addresses for the use of private. Private is nothing but a LAN. LAN is nothing but a local area network. So we will not get the IP. They will not get the internet for the LAN. But public IP address is nothing but a. So who will give that IP addresses? ISP provider will give that IP address, right? Definitely it will get the. You will get the IP address. You will get the IP address. Private IP can only allow certain values. Private IP address can allow only certain values. So for example, in the 10.0.0.0 to 10.255.255 means something like by slash by 8. So it's a big network. So 172.168, this is the class A, class B, class C. Class A, class B, class C. All the rest of the IP addresses on the internet are public. So default VPC walkthrough. All new AWS accounts are having the default VCP. New EC2 instance are launched into the default VPC if no subnet is specified. Defined defaults VPC has internet connectivity and EC2 all EC2 instances inside have a public IP addresses. So we have also get a public and private IP DNSs. So route table and internet gateways. It is helping to you. It is helping to your to traffic will be routing through the VPC. So route table is helping your traffic will be routing through the VPC. For example, route table your Wi-Fi address. So how you are getting your pages? You are getting your pages from the your VPC your route table. Route table is nothing but a Wi-Fi dongle. Wi-Fi dongle, internet gateway. It is attached to my VPC and it gives the internet access to the EC2 instance. Guys, 1 second. Guys, I'm back. Spits. 1 second. So actually, I'm getting the sleep. So I did my face wash, guys. Yeah. So route table. So route table is helping your traffic will be routing through the your PPC. So internet gateway is attached to my VPC. Internet gateway is attached to the my VPC and it gives the internet access to the EC2 instances. So how you are getting internet access to your VPC by using internet gateway? By using internet gateway. What is that, guys? Yeah. So this is the internet gateway. Through internet gateway, you are getting the internet to your EC2 instances. Before, so in your local, you are getting the private IP. Private IP means LAN. In the LAN, you are not getting the internet access. If you want to get the internet access, but you need a internet gateway. Guys, understood?
Yes, sir.
Yeah. So VPC in AWS. So VPC is nothing but a virtual private cloud. So what is that, guys? Virtual private cloud. You can have multiple VPC in AWS region, max 5 per region. So how many you can create? You can create max 5 per the region. North Virginia, Ohio, something like, right? Asia specific, we have a 3 regions, right? So any of the region. So every region you need to take a 5 max VPCs. So max cider per VPC is 5. For each cider is min size of the 128, something like. So once 16 IP address minimum, maximum 655. 36 you can get it. So because of VPC is a private, only the private IPv4 ranges allowed from 10 series and 17 series, 172 series and 192 series. These are the series we are taking. So your VPC shader should not overlap with our networks. So this is the region, this is the VPC. So in the VPC you create the in the availability zone, something like there is a public net and a public subnet and private subnet. So VPC subnet. So AWS reserves for 5 IP addresses, first 4 and the last one in each subnet. So these 5 IP addresses are not available for use and cannot be assigned to an EC2 instance. Example of if CIDR block 10.0.0.0/24, then reserved IP addresses are 10.0.0, 10.1, 10.0.0.0.2, 3. So these are the 4 and last IP address. Guys, it is a network broadcast address. AWS does not support the broadcast in VPC. Therefore, the address is reserved. So if you need 29 IP addresses for our EC2 instances, so in our company, you need a 29 EC2 instances you want to launch. So you cannot choose the subnet of size of 27. So you need to choose the subnet size of the /26. So 64 IP addresses, 64 minus 5, 59 IP addresses. 59 IP addresses. Guys, understood? So internet gateway, through internet gateway. So we are getting the IP, we are getting the internet to your VPC. Allows resources in VPC to connect the internet. It scales horizontally and it is highly available and redundant. Most to be created separately from VPC. One VPC can only attach it to the one IZW and vice versa. So internet gateways on their own do not allow internet access. Robust tables must be also be edited. So this is, yeah, guys. So this is your private and public chat. There is no internet. There is no internet. So you see, guys. So you can attach to your internet gateway, attach it to the VPC. So then, so internet gateway and the router is from the route table. So public to route, then internet you will see. So how you will get the public IP, how you will get the internet access to the EC2 instance. So from internet to outer internet to we need to use the internet gateway. From internet gateway to the router, then router to you will get the IP address. You will get the public EC2 instance is nothing but a internet. So how you are getting internet? How you are getting internet access in our EC2 instances through NAT gateway from the router, then public EC2. Guys, understood? Yeah, guys.
But
Now
how
we will
this
do.
route table
Yeah, I
looks
will
like?
show you. I will show you real time. Okay.
Okay.
Yeah. Create the VPC. For example, demo VPC. So select the 10.0.0./16. So create a subnets like private and public. So you can create the pub subnet B, pub subnet A, and pub subnet B, private subnet A, and private subnet B. Subnets attached to the VPC. Subnets are attached to the VPC, right? So subnets are attached to the VPC. So internet gateway EC2 instance in a VPC connect to the internet. So internet gateway is for connecting the EC2 instance connecting to the VPC connected to the internet. Guys, understood? VPC connected to the internet by using IZW, internet gateway. IZW, create EC2 instance, go to the network settings, VPC, subnet, auto SN, public IP, default to disable, go to public subnet A, select the auto SN and try to connect from the web, but not working due to IZW not added to the demo VPC. So if the internet gateway is attached, then only we can get the pages, right? Then only we can get the pages. So create an internet gateway name like a demo IZW, state is detached and actions attach demo VPC, create a route tables, public route table and private route table and assign it to the VPC and subnet association, public RT to the public subnets and private RT to the private subnets. So public route table routes to the edit routes and add a demo IZW, save the changes and connect the instance. We will do the real time, guys. So Bastion host, so NAT gateway. So AWS managed NAT, higher bandwidth, high availability, no admission, pay per hour per use, and bandwidth. NAT gateway is created as a specific availability zone. Use elastic IPs, can't be used by the EC2 instance. The same subnet, so requires an IZW private subnets, 5 GB Mbps of bandwidth with automatic scale up. 40 to 45%, no security groups to manage required. So this is the NAT gateway. So NAT gateway with high availability. So we can use the NAT gateway with high availability. Security groups. So security group is nothing but a guys. So security group is nothing but a. So for example, so if you want to get the pages from, so you are hitting the www.facebook.com, right? So facebook.com, you want to get the pages from here. So where this deployed code, the code is deployed under the here. The code is deployed under the here facebook.com. So through which protocol? https protocol, http or https, for example http. So the inbound and outbound. So outbound is nothing but a, so if you are getting from here to out, so this is nothing but a out, this is nothing but a inbound. So incoming traffic. So this is incoming traffic. So this is outgoing traffic. This is outgoing traffic. So incoming traffic means you are hitting from outside to, you are hitting from outside to, instance, right? So out, what is outgoing means? What is outgoing? So the outgoing nothing but from instance to out, from out to instance. This is nothing but a inbound. So this is nothing but a outbound. So the inbound rules and outbound rules. Inbound rule and So inbound rules and outbound rules. So who will manage this inbound and outbound rules, guys? Who will manage this inbound and outbound rules? So there is a, yeah, who will manage this? This will manage by the, so this will manage by the security group. Security group, SG. SG is nothing but a security. Security group will manage. Security group will manages the incoming and outgoing traffic. So who is managing? Security group will managing the incoming and outgoing group and outgoing traffic. Guys, now you understood? SG security group.
Yes.
Yeah. Yeah, security group and NACLs. So incoming request and outgoing request. Incoming request and outgoing request. Something like this is your EC2 instance. You attach it to one security group. SG inbound rules and outbound rules. SG inbound rules and outbound rules. So something like inbound or outbound rules, you need to select NACL. So inbound rules, we need to select security group. Security group and NACL. So network ACLs means access control, network access control list. So it will provide the access to access. So network access control list. Networks are the like a firewall which controls the traffic from and two subnets. So one NACL per subnet. New subnets are assigned to a default NACL. Guys, so you don't need this one. This is the advanced, guys. So imperial ports, NACL with imperial ports, so create NACL rules, so security group with NAS. So VPC peering, guys. So VPC peering is nothing but a private connector to VPCs using AWS network. So two VPCs, VPCA, VPCB, VPCC. Three VPCs are connecting with the VPC peering. So we want to connect the VPCs. For example, you created a VPC1, VPC2, VPC3. These are the three VPC peering. So VPC peering, so privately connected to VPCs using AWS network, make them behave if they were in the same network. Must not have a overlapping siders. VPC peering connection is not transitive. So must be established for each VPC that need to communicate with the one another. You must update the route table in the each VPC subnets to ensure EC2 instance can communicate with each other. So VPC, good to know. Something like you can create a VPC peering connection between VPCs in different AWS accounts and regions. You can reference a security group in peering VPCs. So something like you need to create a different VPC peerings, right? So VPC endpoints also there. So VPC endpoints, every AWS service have publicly exposed. So VPC endpoints allows you to connect the AWS services using a private network instead of using the public internet. They are redundant and scale horizontally. They remove the need of IZA, NAT, KZW, and access the AWS services. In case of issues, check DNS settings resolution in our VPC. Check the route tables. Types of endpoints. Gateway or a interface endpoints. So these are the networking, guys. These are the networking in the AWS. Guys, understood? So whatever we discussed, right? So VPCs, subnets, so NAT gateways, VPC peering, network ACLs, right? So VPCs, so NAT gateways, subnets, so VPC peerings, route tables, network ACLs, internet gateway, security groups, so endpoints, endpoint site-to-site VPN, so running instance, endpoint services. These all are the networking services. These all are the networking services. I will show you the default VPC. So this is the VPC. This VPC is the default VPC. So VPC is created. So in this VPC, this is the VPC. So DHCP option set, main route table, main network ACLs. These all are the predefined created. So what is the IP address of he created? So what is the IP address created, guys? So what is the IP address? 172 dot. Guys, tell me. So what is the IP address? 172.31.0.0.16. So this is the IP address for the VPC. So this is the IP address for the VPC. So what are the subnets are they created? The subnet, this is the subnet, subnet. These all are the subnets. The subnet is attached to the route table. Route table is attached to the IGW, Internet Gateway. That's the reason we are getting the, so that's the reason we are getting the internet access. If you use these subnets, so we are getting the access. You see, so it will automatically connect to the route table to internet gateways, route table to internet gateways, route table to internet gateways. Guys, understood? Little bit.
Sir,
So cider blocks. So cider blocks are something like you
sir,
have, yeah,
how many subnets we can connect at a time for one VPC?
one
Like
VPC.
here,
Yeah.
I used 6 subnets, sir.
So subnet is nothing but what is subnet? Subnet is defined the how many IP addresses used in our subnet. One
Yes,
second.
sir.
Got the clear? So subnet is nothing but the range. So how much of the range of IP address, how many IP address we can take for this VPC. So that is defining the VPC. Got you?
Yeah, okay, sir.
Okay. So it is defining the IP addresses. Something like if you take the subnet, yeah, I will tell you. Something like subnet. So one second, someone is pinging. Yeah. So what is that subnet? So subnet, what is that subnet? Private subnet. For example, private subnet and public subnet. Public subnet. The subnet is nothing but, so we can define the IP addresses. How many IP addresses? So for example, if you use the 10.0.1.0/24, how many IP addresses we need to take? So public subnet. So public subnet means 10.0.0.0/24. How many IP addresses we need to take for this? Understood?
Sir, what does this last 24 means?
Yeah. So you see the cider blocks. So the subnets will take the subnet. AWS reserves 5 IP addresses in each subnet. So these 5 IP addresses are not available in the assigned subnet. You can see the cider blocks 10.0.0.1 means then the reserved IP addresses are these. For example, if you choose the /27, if you choose the
Okay,
/27, so that is nothing but a 32. /27 is nothing but a 32 IP address. We can take it. So how many IP addresses we can take it? 32 means 10.0.0, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 32. Okay, but the reserved IP address is 5, right? How many we can take? We can take only 27. So if you use the /24, we can take the 64 IP addresses. So in our application, you want so this is our AWS, this is our AWS, this is your VPC. In our VPC, how many instances you want for deploying your application? You want a 25 VPCs. So every VPC, every 25 instances, every instance we need to set the IP address, right? 10.0.1.5, 6, 7, 8, 9, 10, 12, 13, 10 dot something like we need to set the IP address. This /24, this /26 will defines the how many IP addresses we are using for this subnet. Got you?
okay, sir.
Got it?
Yeah, okay, sir.
So how many? If you need 29 IP addresses of the each instance, if you cannot choose the subnet IP /27. /27 means 32. /26 means 64 IP address. We can take the 64 IP address minus 5 reserved IP address. We can take 59 IP addresses only. So 59 IP addresses we can assign it in the 59 instances. Your application, your total application need a 59 instances. How many IP addresses we need? 59 IP addresses we need.
Yes, sir.
Right?
Okay, sir.
Yeah. So this is the subnet. Your subnet range is 172.31.0.16. 172 dot. So a resource map. This is your resource map. This is your CIDR blocks, tags, integration. So nothing. Okay. And so this is VPCs subnets. So what are the subnets? There are the multiple subnets are there. You can check the any one of the subnet. For example, this is the subnet. So we can take a minimum 5, right? 5 subnets, we can take any every VPC. So subnets. Subnet is attached to the route table and ACLs. So in the subnet there is a route tables. So what are the route tables? This is the route table. Route table is is connected to the internet gateways. Route table is connected to the internet gateways. So internet gateways is attached to the VPC. How you are getting the IP? How you are getting the internet access by IZW? By IZW, you will get the IP address by using IZW, Internet Gateway Service. Internet Gateway Service. Internet gateways, route tables, subnets. So subnets attached to the VPC. So this VPC having the VPC is having VPCs. So it is attached to subnets, right? So attached to the VPC attached to the subnets. So VPC attached to the subnets. Guys, understood? Subnets attached to the VPC. For example, these are the subnets. These subnets attached to the VPC. So right, subnets are attached to the VPC. Internet gateways instance is in VPC connected to the internet. So for example, EC2 instances. So this is your EC2 instance, right? So in EC2 instances, what it has, name is there, instance ID is there, instance state, instance type, water T2 micro, which is status, alarms, availability zone, public IP address, public DNS, public IP, and monitoring is disabled, security group is attached, key name, launch time, so which OS operating system it is showing. And in the details you can see, so details you can see, so details it will be showing instance ID, public IP address, public DNS, public IP address, public DNS, private IP address, private public private DNS, uh, VPC subnet. So your instance is attached with the EPC and subnet. Subnets are attached, right? And so monitoring, there is no monitoring, status alarm, security. If you go to the security groups, what is that? The security group. If you click the security group, it will shows the inbound and outbound rules. It will check the inbound and outbound rules. So the inbound and outbound rules, you are providing the ultra traffic and so outbound from your server to out, all traffic, inbound and all traffic we provided. Right, this is the security group. So this is a security group. So networking. So networking, the subnets are attached to the VPC. Subnets are attached to the VPCs. Subnets are attached to the VPCs. So VPC subnets are attached to the route table. Route table is attached to the IZA. Guys, understood? So this is the a real-time example. I will create you one VPC, guys, for you. Create a VPC. So the VPC name is demo VPC. So demo VPC. The CIDR block is 10.0.0/26. 10.0.0.0 slash. For example, I'm taking 16. So 16 means how many? So the tenancy default name, key name, everything. Created a VPC. So what is my VPC, guys? Demo VPC. What is my VPC? Demo VPC. Demo VPC having no subnets, no route tables, no internet gateways. Yeah, we'll create everything, guys. So we'll create everything. This is my demo VPC. So demo VPC, I need to create the instances within this VPC. I need to create the instances within the VPC, guys. Yeah. So we need to create the subnets. How you can create the subnets? Create the subnets like a private and public. So go to the subnets, create a subnet. So VPC, which VPC, guys? Your demo VPC, attach it to the demo VPC. So what is that, guys? The subnet one. The subnet one, you can take public subnet. So public subnet. Yeah, I'm taking this public subnet. Availability zone, whatever it, guys. You can take anything. So default. So IPv4. So IPv4, how you can take it? You guys take it. Yeah, this is the CIDR block for the VPC. So what is the IPv4 we are taking? So we are taking the IPv4 10.0.0.0.0/24, guys. Slash 24. How many IPs we are taking? We are taking the 256 IPs. How many IPs? For subnet A, public subnet A, we are taking the 254, 256 IPs and add a new subnet. Add a new subnet. So what is the subnet? Pub, pub subnet, public subnet. Again, I'm creating public subnet B. So in the public subnet, you are taking a, so region is default, guys. So you are taking the CIDR black. So this is the VPC, and here you are taking 10.0.0.0/24/24. Yeah. So add a new subnet. So private subnet. So private subnets, I'm taking the availability zone reference. So and the so this is the VPC. So 10.0.0 10.0.16.0/.